in the die castings just because we don't understand the process. And so hopefully in this three-part series that we're doing, you're going to get a nice background into generally what do we need to be concerned about when we try to design a die casting, and hopefully it really whets your thirst for learning more about the die casting process, and it sends you over to the Die Casting Design website, or even sends you to contact die casters and try to more fully understand what they're doing every day. So for us to really understand how to design a good die casting, we really need to understand the die casting process. And that's what we're going to focus on today, is the die casting process and the different variations of the process, some of the aspects of just the process design that we need to consider when we create die casting designs, and then we'll finish up with some really interesting applications of die castings to give you an idea of sort of the breadth of what we can do in die casting. So if you go out in the world and you quote a die cast part, worldwide die casting really stands for any metal being poured into a metal mold. And so that would include things like gravity casting or low pressure die casting or tilt pour casting. Here in North America, we tend to make a more careful distinction, and we say that die casting is really short for high pressure die casting or the high integrity die casting processes. And these are really different from gravity die casting and low pressure die casting. And when we look at all the metal mold technologies for metal casting, high pressure die casting and the high integrity processes are by far and away the largest portion of the market. They contain over, I think, 75% of the market is just high pressure die castings. And so here at NADCA, what we tend to focus on is just these high pressure versions of die casting. And so that's really what we're going to focus on in this series of webinars. Many of the things we're concerned about in high pressure die casting apply in gravity die casting and low pressure die casting and other variants. However, since the large majority of metal mold casting technologies are high pressure, we find it most useful to focus on these. So when we really say die casting in North America, we say we have a very large, complicated hydraulic, electrical, mechanical machine that we're going to use to force metal under high pressures into a metal mold. And so this is an example of a Buehler-Prince machine. I believe this is a 900-ton machine, and that 900 tons means that that machine can apply 900 tons of force to hold that die casting die shut. And so what really is the die casting process? And this is probably the simplest way to explain it. Essentially what I have is a trough or a sleeve which I fill with metal. And once I fill that with metal, then I inject that metal under high pressures and high velocities when we talk about high pressure die casting in particular. Once we have filled that cavity with this high pressure and high velocity, we continue to press on that metal with a very high pressure. A typical pressure might be in the 8,000 to 10,000 psi range. And what that does is it allows us to force extra metal into the cavity as the aluminum or magnesium or zinc starts to shrink and solidify. And we'll talk more about this shrinking and solidifying in the next series, or in the next webinar of this series on Monday, when we talk about die casting defects. But after we've applied that pressure and we've fully solidified the casting, then we actually open the die, and we use that plunger to push the casting into what you see as the left-hand side of that die.